Good day, everyone. I welcome you again to Simplified RSA. We are the guys who makes it look easy. And today we'll be doing physics. Now, before we start, here's something that I want to put out there. It is very much important to understand the interpretation of graphical methods or graphical representations, not just in mathematics, not just in physics, but in any other subjects. You see, you must be able to take information and present the information in a graph, or from a graph, you must be able to interpret the whole communication that the graph is about. Now, that is similar to our question for today. So let me present the question for today. We are given that the velocity time graph below represents the motion of a girl riding her bicycle in a northerly direction. So there we have our velocity time graph. The dependent variable is velocity and the independent variable is time in seconds, and the velocity is in meters per second as well. Like I say, it is very much important to know and understand how to interpret graphs, generally in the academic world, regardless of the subject. So now 4.1, we have to write down the girl's initial velocity. The nature of questions, if you are asked to write down and if you are asked to determine or to calculate, for a case where you have to write down, it means the value is there, visibly there. You just have to take the value and write it down on your paper. Now I'm teaching you how to answer questions. But for a case where you have to determine or calculate, it means you have to work it out on a paper. You have to do the process of calculations to get that. Now, for 4.1, let me share the graph. So for 4.1, we have to write down the velocity, the initial velocity of the girl. The initial velocity, meaning what is the velocity at time zero? That's what we are trying to interpret there. So at time zero, we can see that 0 seconds is here. At time zero, what was the velocity at that time? So it is represented by point A. If you can see point B from the scaling of the graph, it goes 0, 2, 4, 6, 8, up to 12 there. But one can see that this part here, we can say it is 5 meters per second because it is between 4 and 6. So this means then I would say 4.1. So for 4.1, given from the graph, I would say the initial velocity is 5 meters per second, as like that. You can either present it like this or you can just say 5 meters per second. I'm talking about the SI unit representation like that. Now for 4.2, for 4.2, For 4.2, we are required to write down the magnitude of the girl's velocity at 300 seconds. So again, let's look at the graph. And then at 300 seconds, this is the part here, that line going up, and then it touches the graph somewhere there to be accurate. And then at this point where 300 seconds touches the graph, what is the velocity? If I slide to my left, you can see that it roughly corresponds to, I would say, 8.3, 8.4 meters per second there. So to give the velocity of 300 seconds, it would be proportional to the part where it's just that it's not going to be accurate on my side, but then I can tell that at that moment, the velocity is actually 8.4 meters per second. So it would be 8.4. Even if you can say 8.3, it would still be acceptable, I believe, depending on what value you see on your side. But then I would say 8.4 meters per second, which, like I say, I can still represent the meters per second as meters per second. It doesn't really matter the format that you use, but for 4.2, it would be 8.4 like that. So, like I say, the importance of graphical representation, interpretation, or the ability to can interpret graphical methods or graphical representation. 4.3, we have to use the information on the graph to describe the motion of the girl. So for 4.3.1, from point B to point C, and for 4.3.2, from point C to point D. Now, let's look at point B to point C first. Let's ask. Okay, cool. Looking at point B to point C for 4.3.1, we can tell that obviously the slope of the graph is going up and we have a positive slope, which represents that the velocity was increasing between point B and point C. If you can give an answer like that, it would be acceptable that the velocity increases from 5 meters per second to 10 meters per second. And we can also see that the velocity is actually is a positive acceleration of some sort, because now I'm using experience to relate this to acceleration, but then we know that acceleration is change in velocity over the change in time, and it represents the positive slope there, meaning it is accelerating positive, or it's a positive acceleration. But you can give different answers based on how the student looks at this. So one student may say the velocity is increasing uniformly. One student may say velocity increases from 5 meters per second to 10 meters per second. One student may say the girl is speeding up, but all the answers would be acceptable as long as you talk about the relation to the positive slope that we have there between B and C. That's for 4.3.1. And for 4.3.2, we have to determine we have to describe the motion for CD. Now, to describe the motion that is going on between C and D, that would be to answer question 4.3.2. One can see that there is no change in velocity between point C and point D, because throughout that it remains the same. So velocity has been 10 meters per second from point C, and it still remained 10 meters per second at point D, which means that the velocity is constant through CD. And constant velocity means we have zero acceleration between C and D. That would be the answer for 4.3.2. Moving on to 4.4. 4.4.1. Okay, sharp. Let me just read the whole phrase. So without using equations of motions, calculate each of the following. So we have to determine 4.4.1, which is the distance covered by the girl from point A to point C. And then 4.4.2, we have to determine the acceleration of the girl from point D to E. The most important thing here is to be aware when you are given a velocity time graph, for you to calculate the distance covered from the velocity time graph, you have to determine the area under consideration, the area under the graph for the intervals under consideration in that part. So now let's look at our graph. As we are given from point A, B, and C, we have the situation where we have a triangle, as well as, okay, this is the triangle I'm talking about, just to make you understand. So if I construct a line there, we have a triangle. This is the triangle, and we also have the rectangle which is this part here. So we have to add the area under the graph of considerations, which is A, B to C. And I can tell that the width from this side, it would be from here to there, which is going to be, if it's 300 meters here, if it's 300 seconds here and it's 400 seconds here, it is safe to say this is going to be 350 seconds. Ramaphosa's government unemployment fund. And for here, we know that this side is going to be 5 meters per second, because we have determined that when the initial velocity of the girl, it was 5 meters per second, but otherwise we know that from here to there, it's 5 meters per second. So this side will be 5. Now I have to determine the height of the triangle. The height of the triangle is going to be from this point here to there. So the height of the triangle is also going to be 5, because we can see that the graph increases from B to point C. It's 5 meters per second to 10 meters per second, which makes the height to be 5. And that makes the width of the graph, the width of the triangle from here to there, it's going to be the difference of 200 and 350. So that means from here to there, we have roughly 150. So we have 150. So we have determined all the components of our triangle. Now we can answer the question. So 4.4.1, distance of A to C is going to be length times the breadth for the first part multiplied by 1/2 breadth times the height for the triangle. Therefore, there's going to be, the length is 350 seconds multiplied by 5 meters per second plus 1/2. The breadth is 150 as determined on the shape of the width on the triangle, and the height would be 5 as well. If I punch this on a calculator, I'll find that the distance covered is going to be 2,125 meters. So that would be the distance covered by the girl. And now to get the acceleration, 4.4.2, without using the equations of motions, I do understand that acceleration is change in velocity over the change in time. And from the graph, I can see the changes, because if I look at the graph, looking at the graph from here, one can see that for point D, the intervals of point D is 10 meters per second, and the time is, that's the velocity there, and the time is roughly 5:30. Because if it's 500 here, and it's not really between 500 and it's not really between 500 and 600. So I would say here it would be 540 if I was to estimate a proper estimate. So I would say this position here is roughly 540 or 530, and then for point D, for point E, the girl stops at 600 seconds. So between there and there, I would say the intervals for this is 540 and 10. I don't need to put it there, but then it's 540 and 10. So now, looking at the changes, while following the whole thing, I can tell that obviously the final velocity is 0 where the girl stops. 0 minus 10 meters per second. That would be the change of the velocity. And then the change for the time, it would be 600 because she stops at 600. 600 minus roughly 540, something of that form, just to be a bit accurate. And then I can tell that this is gonna be so here we would have minus 10 over 60. Therefore, this is gonna be approximately 0.16 meters per second squared, but it has to be a negative because it's minus 10 divided by 60. So the negative represents that now the girl was moving to the opposite direction according to her original direction, because she was moving northerly direction. Now the negative shows that she was now moving on the south side, on the southern side of the direction. So to put this answer in a final form, I would say this is roughly 0.16 meters per second squared south. That would be 4.4.2. Now, I want you to try this next one. 4.5, we have to determine during which stages of the journey is the change in speed the greatest. That's 4.5. And 4.6, you have to explain the answer to question 4.5. Please share your answer on the comments. What do you think from the given graph? Where do you think the speed is the greatest? During which stage from A up to D? So A, B, C, D up to E. During which stage do you think the speed is the greatest, or rather the change in speed is the greatest? Leave your answer on your comments for 4.4 and 4.6. I mean for 4.5 and 4.6. I'm Mr. Maimane. This is Simplified RSA, and we are the guys who makes it looks easy. Please don't forget to subscribe to our YouTube channel. Follow us in all our social media platforms, and also feel free to contact us to inquire about our private lessons. You can send us an email or WhatsApp from any of these numbers here. And yeah, that's it for today.